Swayam Prabha. Digital India. Educated India.
Hello students. Now in this module I will discuss wave equation. Now you recall that in the first clip in the motivational introduction I discussed a mathematical modeling of wave equation, right? So you know wave equation arises from transverse vibration of a string, which is elastic, and there are some assumptions. Okay. Now, a string can be considered as an infinite string. That means it is sufficiently long, free at both ends. Okay. So there will be a vibration, and naturally this will be a vibration in forward and also in backward. All are progressive wave with a moving forward and backward. Second case can be considered string is a semi-infinite string. That means one end is tied this time, and there will be vibration only on forward direction. Third case is possible, a finite string of length L. Both sides are tied. So that means that times you will have a stationary wave. So in previous two cases, there will be progressive wave. Waves are moving forward and backward. This time, finite string, it will be stationary wave, but there will be modes. Three cases can be considered. In this lecture, I will consider infinite string. Okay, so that means a domain of the wave equation, the position variable x, you remember. I introduced wave equation for infinite string in the previous clip. So domain will be minus infinity to infinity. So let me start this. Let me first show my digital board. So the problem is wave equation. It is del square psi del t square equal to c square del square psi del x square. X belongs to minus infinity to infinity, infinite string, and t greater or equal to 0. Let me label it as let's say 1a. Okay. Let me also write down here c, which is greater 0, is wave speed. This I will explain later after finding the solution, when I will discuss the interpretation of the solution as a progressive wave profile, then you will understand why it is wave speed. Okay, so C is some fixed positive constant. We have initial condition. Initial conditions is abbreviated as IC. Initial means t equal to 0. And then it is psi x0 equal to fx. Okay. And psi t x0 equal to gx. Let me label it as 1b. Okay. And here we find a solution called dilemma solution. Dilemma solution. What I will do? Characteristic directions. You learn that how to find characteristic direction of a second order PD with variable coefficients. So here characteristic directions are xi equal to x minus ct and eta equal to x plus ct. Here one thing I want to tell you, that note wave equation 1a is hyperbolic type, right? So it must have two real characteristic directions. Okay. So along these characteristic directions, we can reduce wave equation 1a into standard canonical form, right or not? So let me go to next page. So reduced canonical form of 1a will be definitely, this time I will not use zeta, I will use psi, it's fine. So that it is del square psi and new variables will be zeta eta. So del zeta del eta equal to 0. Let me label it as, let's say, 2. Now this I actually gave you as a hint, as a homework in previous class. Why? Because you see here, PD2 is a very simple form. So formally, if you integrate PD2, okay, partially with respect to, let's say, xi. That means eta you are considering constant in the process of integration. So it will be del psi del eta, of course, equal to some constant, but that constant definitely depend on xi, depend on eta, because eta is considered constant here. So it will be some, some, or maybe some other variable. So same thing. Let me some arbitrary function of eta. So let me label it as 3. Then integrate this first order PD3 partially with respect to eta, let's say now. So now xi is considered constant. Okay. So that means you will have psi let me write down from far left to get space. So let's say psi xt. It will be then integral h eta d eta, right? Plus some function of xi. Okay. So that means integral h eta d eta you can consider as some arbitrary function of eta. So finally you are getting phi 1 xi is x minus ct, characteristic direction, plus phi 2 x minus ct. Let me label it as 4. So 4 is a formal solution. 4 is a formal solution and phi 1, phi 2 arbitrary function. But it will not be arbitrary. Remember, go to previous first page. There is initial conditions here. When we will apply this initial condition, we will get particular specific form of this function 5152. For this, let me go to next page. Okay, here we get, as we understand, formal solution as psi xt equal to phi 1, right, x plus ct plus phi 2 x minus ct. We go to previous page to see the equation number. I was 3. So, okay. So it is 4. Now, I want to calculate del psi del t. Why? Because go to the first page. There is del psi del t. So, therefore, psi t xt, it will be c phi 1 prime x plus ct minus phi 2 prime x minus ct. Phi. Remember, phi 1 prime u is means ordinary derivative, because phi 1, phi 2 are functions of single variable. So phi 1 prime u is d phi d. Understood? Okay. So now use IC. So first IC is psi x0 equal to fx. Right? Put here t equal to 0. Initial means t equal to 0. Right? So you get fx is a given function. Okay? So you will get phi 1x plus phi 2x. Let us label it as equation 6. Now use this one, psi t x0. Psi t x0 is equal to gx. So that's equal to c phi 1 prime 0 minus phi 2. No, sorry. It should be phi 1 prime x minus phi 2 prime x. Integrate it. Simple integration. So let me label it as equation 7. So integrate 7, but you will get gx maybe 1 by c, and here we are putting an integration. So let me use a dummy variable here, u du. Okay, here you can write when you are integrating, you can always take a arbitrary point here x0, okay, to x. x0 is some arbitrary point on u line, so that this will be phi 1x minus phi 2x. Let me label it as equation 8. Do I need to explain, what is going on here? This is nothing. You may think in this way. Okay. We are actually doing an indefinite integration. So you may think that, okay, if it is indefinite integration, then there will be some arbitrary constant will be on any side. Point is that finally these arbitrary constants can be absorbed. Okay. So always this will be this way. I mean, if you think that if we integrate equation 7 in the interval x0 to x, then on the right side, there must be some term of evaluated at x is equal to x0. Point is that all these are constants and phi1, phi2 are arbitrary functions. So finally, it will reduce to one arbitrary constant. Okay. So it is a right equation. Now, if you consider equation 6 and equation 8, on the next page, I will write now phi1, phi2 because this is our actually target to find phi1, phi2 because phi1, phi2 was arbitrary function in the formal solution. So we are using initial condition to find specific form of phi1, phi2. So if you add and subtract 6 and 8, you will get, let me write down. So from 6 and 8, you will have phi1 u. U is a dummy variable. So phi1 u we will get, which is half fu plus 1 by c integral maybe it is better idea to use dummy variable v here. Let me use phi1 v. Okay. So it will be x0 to v, right? GUD. U is the integral variable here. So what is the equation number 8? So it should be 9. And phi2 v, you are adding and subtract 6 and 8. So you are getting half. One thing I have to change here. 1 minute. This one should be v. Okay. So it is AP. This time minus 1 by c x0 to v GUD. Let me put it as 10. So therefore, going back to previous page, our solution was this one. So phi1 should be written down in terms of x minus ct. This is something wrong, I doubt. Sorry for that. Phi1 xi is x minus ct, but it must be x plus ct. So phi2 must be evaluated as x plus ct. Because xi was x minus ct and x plus ct, right? So let me just fix these things. Psi xt is phi1 x plus ct. So we come here phi1. So okay. Let me just change a little bit conventional things. So del psi del eta is h eta. So okay. Let me little bit change these things. So maybe let us put phi1 eta and phi2 xi, and xi was where? Xi was x minus ct, eta is x plus ct. So I am little bit changing these things. So it's nothing, just to match the things. So it is now phi1 x plus ct. Okay. Plus phi2 x minus Same thing, previous one also right. Just I want to put x plus ct in phi 1 and x minus ct in phi 2 in order to match my interpretation profile, which I will discuss later. Okay. So therefore, we can now obtain dilemma solution. What is that? Psi xt. Remember that, let me go back again. Phi 1 is required for x plus ct. Phi 2 is required for x minus ct. Okay. So that means this is for x minus ct, right? No, x plus ct. So that means, and this is for x minus ct. So you will have one part these things, f x plus ct plus f x minus ct. This is one part. Another part will be 1 by 2c integral x0 to x plus ct gu du, okay, minus integral x0 to x minus ct gu du. Now you see, you can always absorb this minus sign here to change the limit, right? So if you change the limit, I am writing down final solution here. Hence, final dilemma solution for infinite string problem, okay, is, let me use different ink. Psi xt equal to half f x plus ct plus f x minus ct plus 1 by 2c integral x minus ct x plus ct gu d, so that no arbitrary constant will be there in the final solution. Let me again go back to previous page to explain. You see, from here, from this portion, these two can be combined, okay, because it is x0 plus x plus ct gu, and it is plus x minus ct to x0, because it comes from this minus sign. So you will change. So this means basically x minus ct to x plus ct. So this is our final solution. Now there is a good interpretation of this solution. And you see all these things we did, I mean, along the two characteristic directions. So one is x plus ct, another is x minus ct. So let me discuss now this interpretation of this dilemma solution as a progressive wave. So for this, let me go in next page. So interpretation of or maybe this is not required dilemma solution. Solution. Okay. So to interpret let me first write down this. We obtain psi xt for infinite string. There's two parts actually we can write. Let me write down in this way. 2, let me multiply by 2, okay? So that this half factor will be removed. It will be convenient for me to interpret it physically in graph. So let me write down a psi L, L for left, okay? You will understand why I am using this suffix. Psi L xt plus, let's see, psi R xt. Where psi L xt is the combination of the small f. It is f, psi L xt is f x plus ct, right? One minute. 1 minute. Let me tell you one thing. Wait. Let me finish this. We assume here, for this interpretation, for our simplicity basically, we assume gx equal to 0. That means the del psi del t, that means del psi del t initial condition at t equal to 0 for all x. So then if you go back to previous page, you see if g is 0, this integral term will go, and this fx plus ct I rename is at psi L, and this is psi R. Remember, we already obtained solution. Here I am giving you interpretation of this solution as a progressive way, moving forward and backward. Okay. So we will analyze one component, let's say psi L. Similar for, you will understand, similar for psi R. Okay. Now, suppose at t equal to 0 initial time, solution profile psi L x0, let's say equal to some function. Which function you want? Let's say phi x. Some function. And which has, let's say, nodes. Nodes means where the graph crosses x-axis, okay? Where the graph crosses x-axis. So nodes, let's say nodes at x is equal to A and B in psi x plane. That means what I am telling you, that if it is psi, it is x. Let's say at t equal to 0, this is the wave profile. This is basically psi x0, and this is x is equal to A, x is equal to B. Let's say this time. Now, let me go to next page. So what will happen, you see, at t equal to 1 by c. Interestingly, you will see after, that means from t equal to 0, t equal to 1 by c times elapsed. So psi L x 1 by c, since psi l is simply fx plus ct, so it will be fx plus 1, right? So that means if you replace x by x minus 1, it will be fx, which is actually psi l x0. So that's what that means. It means if you see that there was a situation here, right? Psi explain which was x is equal to a and x is equal to b. Now it was psi l x0, which is equal to fx. Now after time t equal to 1 by c, what will happen? It will just go here, retaining its original profile fx, but this time it is now x is equal to a minus 1 and y equal to b minus 1. It is our psi l at x minus 1, 1 by c. So that means at time t equal to 1 by c, it moves in 1 unit distance. So you now process similarly. I mean, consider at t equal to 2 by c. So you will get psi l x comma 2 by c. So you understand, it will be f x plus ct, right? So fx plus 2. So that means psi l x minus 2 by c is actually fx, original profile. So you see profile is moving leftward. That's why I am using the suffix left. Now if you analyze the other component psi r, you will see wave will move. That wave will move right direction. So if for infinite string, there will be a mixture of wave at any point of time. One wave will be go left direction, one will be go in right direction. So it is psi l x0 again. So in this way, you see, if you now find a t equal to 1, so then psi l x1, no, it was 1 by c, 2 by c, okay, 1. So that means you will have fx plus c. So that means psi l x minus c 1 will be fx, which is the original profile psi l x0. That means, therefore, what you will understand, therefore, after the unit time, wave moves left through distance c. What does it mean? This means c, which is a greater zero quantity, is wave speed. That's what I told you. I will explain why it is wave speed. Okay. Similarly, if you analyze the right component, you will see wave is moving rightward. So basically, if I try to write a diagram handwritten, so basically it will be like this. one wave will be go in this way, okay, in left direction, and another will be maybe some different profile, which will be moved in this form, in this way. Right, this is psi, this is x. So point is that here, for infinite string, waves are propagating freely in both directions. Hence, these are called, as terminology, progressive wave. In contrast, for wave equation for finite string, you will see there will be stationary wave. Okay, that I will discuss later. Progressive wave. So that's it. So that is all for today. So in next class, I will take up wave equation for semi-infinite string, and then I will go for finite string. Till then, goodbye.